Hi everybody! So this video is on scientific notation. And as you can see, I have a picture of our notes that we took in our notebooks. So your notes should look like mine, and we're going to go over what we wrote. Scientific notation is a way to write really, really big numbers or really, really small numbers. Okay, so oftentimes scientists are studying things that require really big numbers, for example, space, that really, really wide space or really large objects or distance away. They're using really big numbers. Or even something like scientists who are studying bacteria or molecules under the microscope, things that are really, really small. Those are decimals that are teeny tiny numbers. Okay, so we write in scientific notation to describe really big or really small numbers. So here's our example here. All right, 52 million. Just the number written itself out with all its zeros, whether it's a big number or a small number, is called standard form. And then we are rewriting it. So it is whatever the number is times 10 to some exponent value. What this looks like right here, that is scientific notation. Now, if we're looking at a really big number with a lot of zeros, it's going to have a positive exponent. If we're looking at a really small number, a decimal with a lot of zeros, it's going to have a negative exponent. Okay, so these are the two forms that we see numbers written in. Sometimes I'm asking you to change a number from standard form into scientific notation. Sometimes it's the other way around. I'm giving you a number in scientific notation. Can you write it in standard form? There are two steps that I gave you to write in scientific notation. Step one is you need to move the decimal place until you have a number between 1 and 10. And then step two, you're counting how many places you moved. That will determine what your exponent is, what we're multiplying 10 to whatever the exponent is. Okay, so for our same example right here, 52 million, this is a really big number, and I want to move our decimal place over so that this number becomes a number between 1 and 10. So if I can move this decimal place over here, we know that any zeros after the decimal place have no value. So I'm going to keep on moving this decimal over until we get to 5.2. Now we could move it right here, right? But that would be 52. So still too big. It needs to be between 1 and 10. So I end up moving this decimal place all the way over right here between the 5 and 2. So I end up in the beginning of my scientific notation written out, it is 5.2 times 10 to what exponent? How many places did I move it over? I moved this decimal place over 7 hops. So it'll be 10 to the power of 7. Okay, so these two are equivalent. They're written in standard form. This number is written in standard form and then in scientific notation. Okay, so again, this is a big number, so our exponent is positive, but we're about to do some examples where the exponent will be negative as well. But let's go ahead and get started. So this is a really big number. I need to move the decimal place over so that my number becomes a number between 1 and 10. So here's my decimal place. This is where it normally goes. If I scooched it over, it's going to have to go all the way right here so that it becomes a number between 1 and 10. So we have 3.27. And again, it is a big number, so my exponent is going to be positive. How many places did I move this decimal? 1, 2, 3, 4, 5 places. So this number written in scientific notation is 3.27 times 10 to the 5th power. Let's try another one. This time we have a really small number, so my exponent is going to be negative. So again, we're going to move this decimal place over to as far as we need to go so that it becomes a number between 1 and 10. If I moved it right here, this would be 0.23, still too small. So it needs to go right here. So it's going to become 2.3 times 10 to some negative exponent because it is a really small number. It's a small decimal. How many places did we move this decimal? I forgot to count. 1, 2, 3, 4, 5, 6. 6 places. So it is 2.3 times 10 to the negative 6th. Let's try one more. A number that is small. Okay, so we're going to have some negative exponent. We got to move this decimal place over so it becomes a number between 1 and 10. So we're going to move it right here. 1.09 times 10 to the negative exponent, because it is a decimal, small number. We moved it 1, 2, 3 places. So it becomes 1.09 times 10 to the negative 3. All right, hope this video helped.